Year 6, Lesson 8, Extensive Challenge, Question 2. The diagram shows triangle ABC, in which ABC is equal to 72 degrees and CAB equals 84 degrees. The point E lies on AB, so that EC bisects BCA. The point F lies on CA extended. The point D lies on CB extended, so that DA bisects BAF. So we want to show that AD is equal to CE. That means the line from A to D is equal to C to E, this line here. So our goal is to show that these two lines have the same length. So let's see. Now, the two angles we're told about, 72 degrees and 84 degrees, are both angles as part of this triangle ABC, as labelled. So we can try and find the missing angle, which would be this angle at point C. So, using our angles in a triangle, add up to 180 degrees, that's the interior angles. We can see that the angle at point C, or ACB, is going to be equal to the difference. So they should all add up to 180 degrees. So we want to find ACB, we'll subtract the two that we know. So we get 180 degrees minus 72 degrees minus 84 degrees. And that's going to give us 156 from 180, which is going to be 24 degrees. Okay, now that's the whole angle, which we can see is broken into two angles. Now from the question, we knew that EC bisects BCA. So that means the line through the middle cuts it into half, into two equal pieces. So therefore, BCE is equal to 12 degrees, that's the first angle, and ACE is also equal to 12 degrees. So we've divided that in two parts. Okay, so now we know that we've got those angles, we can start to look at some of the other angles in these triangles. So we could also find out these angles here. Okay, so by looking at the triangle ACE, we can find the angle at E, so that's AEC. So let's work down the bottom. Angle AEC is going to be equal to 180 degrees, which is the total in the triangle, minus the 12 degrees, which we've worked out, and also minus the 84 degrees, which we already know. And that's going to give us AEC, which is going to be equal to 180 minus 96, which is equal to 84 degrees. So what that shows us is that this triangle, ACE, is an isosceles triangle, and therefore AC must be equal to CE. Okay, we knew that because it had two identical angles, 84 degrees. So these make the base angles of our isosceles triangle. So that has shown us that AC is equal to CE. So we're getting there. What can we look at next? So next we can see that the angle, let's have a think. So now we can try and find the rest of the angle, because we can see that F was an extension of CA. So we can look at the angles on a straight line here, which gives us, we could find BAF. BAF is going to be equal to 180 degrees on the straight line minus the 84 degrees, which is going to be 96 degrees. That's the total. So again, we were told that that line, DA, bisects BAF. So that means I can cut it into two parts, and I'll divide it by 2, and I get 48 degrees, which is going to be this angle here, and this angle here. Okay, so finally, we can start to look at this line AD. Now that's part of the biggest triangle, ACD. So let's just try and find the missing angle, which will work over here. So ADC is going to be equal to 180 degrees for the whole triangle, minus 24 degrees for DCA, and then also minus 84 times 2 and 48. So let's work out the sides of this angle, shall we? That's going to be 84 times by 2 is 168 plus 48 degrees. That's 168 plus 48, or in other words 200. 84 plus 48 is 132. 24 minus 132. And that's going to be equal to 156 from 180, which is 24 degrees. So this is 24 degrees, and so is angle BCA. Then we've got another isosceles triangle, which means AC is equal to AD. Now, if AC is equal to AD, we've already known that AC is equal to AE. So therefore, AD is equal to CE as required. AC equals to AD, which is also equal to ACE, as we worked out previously. So now AD is equal to CE as required.